Okay, so for our project, we decided to do a doorknob assembly. This is Team 15, the group names right there. This is just table contents. All right, for this project, we decided on a doorknob assembly to use as our mechanical object. We got this through one of our team members, Mario. He just happened to have an extra doorknob at his house, and we analyzed it and found that it did have the necessary parts and components for our purposes. The outcomes was to analyze it, draw the free body diagram of all the individual parts, and learn the importance of each part and the materials, and then two, as a team, communicate and come together and do the whole free body diagram of the whole assembly. So this is just pictures of the actual whole assembly. The function of a doorknob, as you may know, is just to open doors in everyday houses. Our particular doorknob here is the one that uses a interior lock and key on the outside. Applications would be any household door. The manufacturer for ours was Kronos Privacy. The cost varying from $15 to $20 depending on the complexity of the doorknob assembly. And the operation conditions would be just any residential home, usually at room temperature or sometimes outside ambient conditions. Materials were made up mostly of brass with some steel parts as well. These are the properties for brass: the elastic modulus, tensile strength, shear modulus, and the Poisson ratio. The source, like I mentioned before, was one of our team members, Mario. He provided the whole assembly for us. This is a free body diagram of the assembly as a whole. You can see here the known force would be the moment that's created when you turn the knob, and that in turn would turn the lever inside, which is called a spindle, which then would go into the cam slot, reseating the latch, allowing us to open the door. It does change a little when the door is locked or unlocked, and I will go into that a little bit later. So this is the exterior knob, or the one that requires a key to open it. And this one right here, known force, well, these are just the properties here, sorry. And with the mostly made of brass with the following properties. This is just a free body diagram of the exterior knob, where the known force here would be, like I said before, the moment created when you turn the knob. And the unknown forces would be the two forces that come from the mounting screws as support reactions, and then also the moment that's created on the inside, which is transferred into the, the spindle part that allows us to open the door. And the next part would be the other side, the interior knob. Almost the same thing, same material, same properties. The only difference here is instead of a key, it has the locking driver. And I'll explain that a little bit later, more in depth. This is a free body diagram of the interior knob. Again, the known force would be the moment created when you turn the knob. And we have forces on the screw supports, and then on the interior side of the knob, the part you don't see, there's also forces created with another part that I'll explain a little better as we go on in the presentation. It's depicted here by forces 2 and 3. The next part will be the locking mechanism, which is what I mentioned right now. This is the part that activates when it's locked or unlocked. So depending on if it's locked or unlocked, it'll have different functions. These are the properties here again, made up of brass. It does have a spring as well, but it's very small. The known forces here, again, would just be the moment created, here depicted by the circular arrows. And depending if it's unlocked, when you turn the knob, it would create a force on the two right and left supports that are part of the interior knob. And when it's locked, this locking tab comes up and it does not allow the knob to turn, creating also a reaction force between the locking tab and the interior of the doorknob. And for the spindle and the driver, this is what actually rotates when you turn the knob. It varies if it's locked or unlocked, like I said. It's actually made up of two bars. The outer one, circular, half circle looking one, is the one that turns the whole assembly. When you lock the driver, the silver bar in the middle would rotate, causing the locking tab shown in the previous slide to come up and not allowing the doorknob to turn, hence locking the assembly. This is the same brass, the same properties. This is a free body diagram of it. Again, the moment created when you turn the knob is our known force. Our unknown force here would be the reactions on the cam and on the locking mechanism. The last part for our assembly would be the cam or slot latch. This is what actually allows the door to be open or closed. It's made up of a few different materials. This is the most diverse part, you could say, as a brass casing with a steel spring, and then the cam slot is actually made of a plastic. These are the properties for the plastic and steel. The free body diagram of the slot latch assembly is shown right here. Our known force would be force 1, depicted here by the arrow, horizontal arrow. That is created by the moment that is created when you turn the knob. This would cause the cam slot to move to the right, compressing the spring that's inside the assembly, which would then receive the actual door latch and allowing the door to be swung open. So unknown forces would be 3 unknown forces here. The force that's created on the cam slot, the compression of the spring, and finally the pulling of the latch inside. And our conclusion, we chose the doorknob to disassemble, evaluate, and although it is made up of many different parts, there's more than 5. For our intents and purposes, we broke it down into 5 individual parts since we had 5 team members. We actually thought it was a good choice because we learned about all the little parts and all details that go into the doorknob. Even though it's an everyday object, it's very complex in a way, the way it works. And by doing this, by splitting it up, we were able to analyze how the forces are transmitted through the whole body, and starting from the simple turn of the knob, going through the whole assembly, through the latch, the cams, and the locking mechanisms, and thus allowing us to understand how the doorknob assembly works better. We did have a video that we watched, which was really helpful. It's here included in the link in case you're interested in learning a little more. And yeah, it should just be noted that depending on the assembly, the design and functions of the parts might vary slightly.